So we're going to go into parallel lines, and there's actually the key idea that I want you to get is the alternating interior angles. Pos theorem. I think it's theorem. Sorry. I just need to get back to it. Okay. The alternative interior angles theorem, the corresponding interior angles theorem, and the alternative exterior angles theorem are all have converse. So let's write out their converse. So the converse of this one, if there is a pair of if each pair of alternating it's alternative, yeah, alternate interior angles is congruent, then the two lines forming them actually, yes. Hold on, people. Need to write this differently. It's not going to be interesting, but this is going to be the converse. So if there's two lines are midline. This is in the book. I'm just gonna are cut by a transversal. Such that, okay, I'm actually going to list all of them. Such that, so the AIA is going to be such that each pair of alternate interior angles are congruent. CIA, which is the so that a pair of consecutive interior angles are supplementary spelling supplementary or yeah, so that alternate so that each pair, sorry, apologies, trying to write this out, trying to keep track of all of these, so that each pair of alternate exterior angles. Alright. And then if it's a perpendicular transversal, but we'll talk about that one later in a second. If any of these are true, then the two lines are parallel. So this is the converse of the theorem before, but all of these are true too. So that makes it a biconditional statement. So that is to say, if two lines in a plane are cut by a transversal, such that each pair of alternate interior angles are congruent, then the two lines are parallel. Okay, so this is our conclusion. Okay, so each of these, or any, prove that two lines are parallel. And this is below the theorems, not the constructions, but the proving parallel lines. So corresponding angles, so if two lines are cut by a transversal such that their corresponding congruent angles corresponding angles are congruent, then the lines are parallel. Okay, so this is a postulate. So if corresponding congruent angles are congruent, then the two lines are parallel. Okay, parallel postulate, if given a line point, not on the line, there is exactly one line through which the parallel, there's a parallel point. Okay, if you want to draw a parallel line, there are steps. You use a straight edge, draw that, then you make an angle, then copy the point, you do the exact same angle, and should be possible. Okay, and then there's perpendicular transversal. If plane is two lines that are perpendicular to the same line, they are parallel. Okay, that just means if they form right angles. So there's some practice we can do, some guide practice. So let's look at that. Okay, guide practice. I'm going to give you some of these. Sorry, let's switch this up. Okay, it's going to take us a few minutes. So, we want to prove that these two lines are parallel, these two angles. So remember the postulate they gave us is corresponding, the corresponding angles are congruent, then the lines are parallel. So are these corresponding angles? Well, yes, because, well, why can we say that? Because they're found in the same side and same side of each of the lines. So that's corresponding angles, and so x equals 48. We have two parallel lines. Okay, what about this situation? Okay. Now find x so that these two are parallel, C and D. What would x have to be? This would follow the perpendicular transversal theorem. So 2x plus 8 would have to equal 90, and then you'd solve from there. Okay, this is alternate exterior angles, right? Alternating exterior. So what would these two have to equal? They'd have to be equal, so you would solve for x. Okay, and here's a problem I'm going to give you. So look at it and think about how you're going to solve it. Solve for x so that C and D will be parallel. And finally this one. Okay? Okay, these will all be there for you to practice. And we'll talk about what Wednesday will be like. We'll get to class. See you until then. Bye guys.